All right, welcome to tonight's video on part 4 of Unit 1. We're going to be talking about the law of sines, law of cosines, and how to find the area of non-right triangles. So notice we've talked about not every triangle is a right triangle and the general and unit circle definition for trig functions. Now the question is, how do you solve a non-right triangle? Including triangles that have an obtuse angle. And we have two ways to do that. We have what's called the law of sines, which is written below, and we have the law of cosines, which is written below. So the first thing we're going to do is derive them. So first of all, the law of sines, we're going to label the sides opposite, so A, B, and C. And then the angles, so this is alpha, beta, gamma, and then the height of the triangle right here. And then the vertex at C, we'll notice we don't know what the x-coordinate is, but we know the y-coordinate is the height. So now step 5, we're going to find the sine of alpha. And in order to find the sine of alpha, because it's obtuse, we use the reference angle. So that means it's the opposite over the adjacent, or, opposite. We could do y over r, or we could do opposite over hypotenuse. So basically it's the height over the radius, which is b in this case. The sine of beta, well, now if we use the big triangle, right triangle here, for beta, the sine of that would be the height over A. When we multiply to solve for the height, we get B sine alpha equals the height, A sine beta equals the height. Since they're equal to each other, we can set them equal. And then divide. So now we get sine alpha over A equals sine beta over B. And that also can apply to sine gamma over C. So that's the law of sines. The law of cosines, similar stuff going on. We'll label the sides and the angles. Sorry, need to erase that. So this is side A, side C, side B. We got the height here, we got alpha, we got beta, we got gamma up here. Then we also got D is the length of the segment from A to the height. So this is D. And then from B to the height is C minus D. So now the right triangle definition for sine alpha, we'll notice right here, sine alpha. We're going to do H over B, height over B. And then for cosine alpha, we're going to do D over B. So if we solve these here, we get H equals B sine alpha, and D equals B cosine alpha. So now we're on step 6, where it says using this right-hand triangle, Pythagorean theorem, so h squared plus c minus d squared is equal to a squared. We know h is b sine alpha. We know d is b cosine alpha. So now we can solve using the Pythagorean. We can just do some algebra here. We got b sine squared plus, and then when we FOIL, we got c squared minus 2bc cosine alpha plus b squared cosine squared alpha equals a squared. Now, we can use an identity because remember we know that sine squared plus cosine squared equals 1, right? And this is actually going to be b squared here. So, we can factor out the b squared, so we know b times sine squared alpha plus cosine squared alpha plus c squared minus 2bc cosine alpha equals a squared. So notice that is 1, so b squared plus c squared minus 2bc cosine alpha equals a squared. And notice that is one of the law of cosines. We could prove the other ones the same way. So that is how you prove or derive the law of cosines. Things to remember. The law of sines is used when you are given an angle and its corresponding side. Otherwise, you can use the law of cosines. Beware of the ambiguous case of the law of sines. We'll talk about that. And when using the laws, right, when using the laws, you may need to keep the values in your calculator so you can use them without rounding. We've talked about that. So first, here you're given 3 sides. Whenever you're given 3 sides, you're going to start with the law of cosines. All right, so I like to draw the picture. So here, it doesn't matter in this case where you put A, B, and C. So, for this one, A equals 7, B equals 8, C equals 9. So you need to use the law of cosines. Now, I always use the law of cosines to find the bigger angle, because if I want to use the law of sines next, then I need to know that that I've already found the biggest angle, because the law of sines, you cannot find obtuse angles. You cannot find obtuse angles in the law of sines. So I would use the law of cosines to find the biggest angle, which is going to be gamma in this case. So I would say 9 squared is equal to 7 squared plus 8 squared minus 2 times 7 times 8 times cosine gamma, right? And when I've solved this in my calculator, I'm going to get that gamma is equal to 48.190 degrees. Now, you can keep doing the law of cosines if you want to find the other angles. Or sorry, gamma is not 48.190. Gamma is 73.398 degrees. Now, I can use that, or I can use the law of sines to find one of the other 2 angles. So I could say, if I want to find beta, I could say sine beta over 8 is equal to sine 73.398 over 9. I could cross multiply, divide, and take the inverse, so then I get beta is equal to 58.412 degrees. And then I could subtract from 180 to get what alpha is. So remember, when I'm writing these out, is going to equal 180 minus 73.398 plus 58.412. All right, so when I solve this, I need to make a table. So I know side A is 7, B is 8, C is 9, and I know alpha is going to be 48.190. Beta is going to be 58.412 degrees. And gamma is going to equal 73.398 degrees. And that is your answer here. Now for number two, notice that you're given two angles and a side that is not opposite one of the angles, but because you're given two angles, you can use the law of sines. So if we go A, B, C, and this is gamma, beta, alpha. So beta is 7, alpha is 24 degrees, gamma is 50 degrees. We can use that to find the third angle, right? Because if we go for beta, if we go 180 minus 24 plus 50, then we will get 106 degrees. So there we know the angles. We also know side B. So therefore, we can use the law of sines to find angle or side A and side C, because we can set it up as sine 24 over A equals sine 106 over 7 equals sine 50 over C, and we can solve for A and C. A would be 2.962 and C would be 5.578. So if we're given two angles and the non-included side, so this would be like an angle side, we would use law of sines. Now, here you're given one angle, but you're not given the side opposite that. So this would be what's called a side angle side case, where if you drew this, right, here's A, and alpha is 16. Here's side A, beta, and gamma. So here's side C is 6, and B is 25. So notice you're given the side angle side. So you would do the law of cosines. So you would say that A squared is equal to 25 squared plus 6 squared minus 2 times 25 times 6 times cosine 16. And when you solve for A here, you're going to get that A is equal to 19.303. So then, once you solve for that, you can use the law of sines, right? Because now you can say sine 16 over 19.303 is equal to sine beta over 25, which is equal to Now, here's the thing, and this is a good point I made earlier. Actually, I would want to find gamma first, because remember, with law of sines, you cannot find an obtuse angle. So I don't know if this is an obtuse angle. So I want to find the smaller one first. So I'm going to go sine gamma over 6. When I solve for gamma, I get that gamma is going to be 4.915 degrees, which means then that beta is going to be 180 minus 16 plus 4.915, which is equal to 159.085. If you try the law of sines to find the biggest one, you're actually going to get the supplement of b. You're not going to get b. So when you make the table here, that side A is 19.303, B is 25, C is 6, and then the angles alpha, which I didn't put first, alpha equals 16 degrees, beta equals 159.095 degrees, and gamma equals 4.915 degrees. So there's your chart. So when do you use the law of cosines? Well, there are two cases: when you're given 3 sides, or you're given 2 sides and the included angle, which means the angle that is not opposite the side that you're given. Every other time, you're going to use the law of sines. Now, there is a special case of law of sines, which is called the ambiguous case, and that is when you're given an angle and 2 sides. You can call it side-side angle. And you should always set up, this is an important step here, you should always set up the picture the same way each time, with the given angle as the lower left vertex. So depending upon which letter is the given angle for the side-side angle, you want to put that in the lower left. If there are 2 triangles, the first angle you find will be supplementary to the first angle in the second triangle, and we'll talk about that too. So here's kind of the situations that you can come up with here, and how do you tell? Well, if the side opposite the angle you're given, that's what side A is in this picture, is less than the height of the triangle, there's no solution, right? Because you can't connect. If it's equal to it, that means it's a right triangle, right? If it's equal to the height. There are 2 solutions when the side opposite the angle you're given, which is this one right here, the A, is between, it's bigger than the height, but it's less than the other side. It's bigger than the height, but it's less than the other side you're given. That means you have 2 solutions. And we'll talk about how you do that. And then there's 1 solution if the side opposite is greater than the other side that you're given, or equal to it. Then you have 1 solution automatically. So here you're given a situation. It says gamma is equal to 29, so you would put gamma here in the lower left corner, and b is equal to 14. So b is going to be the other one, because side C would be opposite gamma. So how do you find the height? Well, you find the height by taking 14 times sine 29, which is 6.787. So there's 0 triangles, remember, if that side is less than the height. So 0 triangles if C, right, or sorry, yeah, if C is less than 6.787, right? If C is less than 6.787, then there's no triangles. There's one triangle if C is equal to 6.787, or if C is greater than or equal to 14, right? If it's greater than or equal to the other side. There's two triangles if C is between the two. Right? There's two triangles if C is between the two. So that's how you tell if there's two triangles. All right. So the first thing you can do whenever you're given a side or an angle, a side-side angle, is you can draw the picture. Now remember, this always goes in the lower left corner. So there's beta, right? That's 36 degrees. So then 11 is here. I'm going to put the next, since this is A, I'm going to put that next to it. So A is going to have to be here. This is alpha. And then gamma is up here. And C would be down here. All right, so two triangles possible. Well, we need to find the height first. So the height is equal to, in this case, 15 sine 36. Well, 15 times sine 36 gives you 8.817. Now, since 11 is between 8.817 and 15, that means two triangles are possible. And here's how you draw those two triangles. So you're going to draw basically a line down here, and this is going to be side B as well. All right, so this is your first triangle, and the big triangle is your second triangle. So the first triangle is the small one, the big one is the second one. So if you look at triangle 1, remember the angles are alpha, beta, gamma, right? And then you have side A, B, and C, right? Well, what you are given was, you were given beta was 36, and side B was 11, and side A is 15. So everything else is going to be unique to the first triangle. So this is going to be alpha 1. This is going to be gamma 1 right here. And then this is going to be side C1 right there. In the second triangle, you're going to have the same thing, except now the only thing you're given is beta. But now everything is going to be unique to the second triangle. A is 15, B is 11, and now side C in the second. So the big triangle, that would be, so this is going to be gamma 2, and this whole thing, or that's alpha 2, and this whole thing here is gamma 2, right there. So now, one thing to keep in mind is what you get for gamma 2 here. What you get for gamma 2 here is going to be supplementary to what you get, because notice this is an isosceles triangle, so that means this angle and that one are the same, which means they're going to be supplementary to gamma 1 and gamma 2. So first I got to solve for gamma 2. So I can do the law of sines. So I'm going to go sine 36 over 11 is equal to sine gamma 2, or alpha 2, I keep saying gamma, it's alpha, over 15. So when I do that, I'm going to find that alpha 2 is 53.276. So that is this angle right here. Now to find gamma, it's alpha 2, not gamma. I keep switching them. 53.276. All right, alpha 1, I'll get it right one time. Alpha 1 is 180 minus 53.276. So that would be 126.724. That is alpha 1. Okay, so now you have those two angles right there. To get the third angles, you can subtract, right? So gamma 1 is equal to 180 minus 36 plus 126.724. Right, so if I do that, you get 17.276 degrees. And I can do the same thing here, and I get gamma 2 is 90.724 degrees. So that's basically now all I need is find side C for both triangles, and I can use the law of sines, set it up so that I can say sine of, in this case, sine of, because I'm trying to find side C, so I can say sine 36 over 11 is equal to sine sine 17.276 over C1, which is equal to sine 90.724 over C2. And you can find the values of C1 and C2. C1 is 5.556 and C2 is 18.713. So there are your two triangles. You need to have both triangles in this situation. All right. So the area formulas. All right. So now we're talking about geometry again. And remember, the area of a triangle is 1/2 base times height. While this is still applicable, you're not always given the base and height of the triangle because it's not a right triangle. So therefore, we have 3 types of additional area formulas that can be used to find the area of a triangle. Type 1 is when you're given 2 sides and an angle. For the triangle at the left, notice if you draw in the height, right, you draw in the height, then the height here, right, if you do sine alpha, right, is height over C, so that means the height is C times sine alpha. Sorry, giving me trouble there. And then on the other side, it would be A times sine gamma, because notice if this is gamma, right, the sine of gamma would be h over a. So by substituting these into the original area formula, you get 1/2 base BC sine alpha, or you get 1/2 B A, so we'll say AB sine gamma. And rotating it around, we could also get 1/2 AC sine beta. So those are three different ways. We can say that the area is equal to 1/2 AB sine gamma. We could say the area is equal to 1/2 AC sine beta. Or the area is equal to 1/2 BC sine alpha. There is another type where you're given one side or two or three angles. If you go two angles, you could find the third one. And it's the same type here using the law of sines. If we cross multiply, right? Cross multiply, we get that A is equal to B times sine alpha, right? Because we cross multiply, B times sine alpha divided by sine beta. If we deal with these two here, we get that B is equal to C sine beta over sine gamma. And if we use the last two, the first and last, we get C is equal to A times sine gamma over sine alpha. Which by substitution here, right, because if we substitute what we know that A is equal to B sine alpha times sine beta, and then times B sine gamma, right, because this part has to stay. So that means the area is equal to 1/2 B squared, or if we want to make it an easier fraction, we could say it's equal to B squared, B times B, sine alpha sine gamma over 2 sine beta. And then here, if we do the same thing, but we substitute in for the B, we get 1/2 C sine beta over sine gamma times C sine alpha. And then notice this becomes C squared sine beta sine alpha over 2 sine gamma. So you should notice a pattern, depending upon which side you're given, how it works out. And over here, we're going to substitute in for the C, right? So it's going to be 1/2 A sine gamma over sine alpha times A sine beta. So it's going to become A squared sine gamma sine beta over 2 sine alpha. So those are three area formulas if you know one side and two angles. The last type of formula is Heron's formula. If you look at the learning opportunity on page 307, number 24, there is a refresher on how to derive Heron's formula from that. But basically, the S here stands for the semi-perimeter of the triangle, meaning you take side A plus side B plus side C and divide by 2, and that is the semi-perimeter. But otherwise, you take the semi-perimeter times the semi-perimeter minus one side, times the semi-perimeter minus the other, times the semi-perimeter minus the third, and square root that, and that gives you the area of the triangle if you're given 3 sides. So yes, these are the formulas that you need to know for the area of a triangle and how to find it based on what you're given. All right, my suggestion is to practice. You can do the cumulative review, or you can do some of the learning opportunities, either one. You might want to start the cumulative because you do have your test coming up next week. If you have any questions, I should be back on Tuesday to answer them. All right, have a good weekend.